concept is binomial theorem for rational index. Binomial theorem for rational index. See, you should remember this following result. 1 plus x whole power n is equal to 1 plus nc1x, nc2x square, nc3x cube and so on like this. See, if mod x is less than 1, mod x is less than 1, whatever may be n value, you can expand like this. 1 plus x whole power n is 1 plus nx. nc1 is n. Plus n into n minus 1 by 2 x square. Plus n into n minus 1 into n minus 2 by factorial 3 x cube and so on like this. So if mod x is less than 1, whatever may be n value, you can expand like this. See, earlier we have seen this type of expansion for positive integer values of n. If mod x is less than 1, you can expand for any value of n. For example, n is equal to, let us say, minus 1. You can write like this. 1 plus x whole power minus 1 is 1 minus x plus minus 1 into minus 2 by 2. Right? Minus 1 into minus 2 is 2. 2 by 2 is 1. We will get x square. Plus minus 1 minus 2 minus 3 by factorial 3x cube so on. This will give you like this. X power 4 up to infinity. And you all of you know this. This is equivalent to a by 1 minus r. It's a geometric progression of infinite number of terms. What you are going to get? A by 1 minus r means a is 1. Right? R is what? Minus x. So 1 by 1 plus x. 1 by 1 plus x is as good as 1 plus x whole power minus 1. Suppose n is equal to, let us say, 1 by 2. 1 plus x whole power 1 by 2. 1 plus half into x plus 1 by 2 into 1 by 2 minus 1 by factorial 2x square and so on. So you get 1 plus 1 by 2x. Right? This is half minus 1 is minus 1 by 2. So you get minus 1 by 8 x square and so on like this. Simply wherever n is there, you put these numbers and just expand this. This is what you are supposed to do. So binomial theorem for rational index means, you remember this, nc1, nc2, nc3, all of you know how to write them. If mod x is less than 1, you are at liberty to expand like this. Okay, understood? See, in this connection, you are also supposed to remember one important result. Coefficient of x to the power of n in 1 minus x whole power minus r is n plus r minus 1 cr minus 1. So this is a useful result for us. Just to remember this result. Coefficient of x power n in 1 minus x whole power minus r is n plus r minus 1 cr minus 1. Suppose you come across a problem like this. find the square root of 4.02 like this. Then you have to put like this. Square root of 4 plus 0.2. 4 plus 0.02 like this. You take out 4 outside. 2 into 1 plus 0.02 by 4 whole power half. This is 2 into 1 plus, this is how much? 0.005 whole power half. 2 into binomial theorem for rational x. 1 plus x whole power n. 1 plus nx, n into n minus 1 by factorial to explain. 1 plus n into x, 0.005. Next you are going to get 1 by 2 minus 1 by 2, 0.005 whole square. See, this can be neglected because we will go up to only 4 decimals. If you observe this, you will get what? 0.005 means 5 square is 25. Then you should get 6. So 0.00025 you will get. So after 4 decimals you can neglect. So this quantity can be neglected. We will consider what? Only these 2. So this will be 2 into 1 plus 0.00225 like this. Okay, understood? So you can simplify this. You will get approximation like this. Yes, understood? So whenever the decimals are more than 4, after point if you get more than 4 digits, you can neglect it. Let us consider cube root of 8.02. Cube root of 8.02. Then you can write like this. First 8 plus 0.02 whole power 1 by 3. You take out 8 common. 1 plus 0.02 by 8 whole power 1 by 3. 8 plus 0.02 by 2, 0.2 by 8 whole power 1 by 3. So this is 2 into 1 plus 0.0020, okay, to 5, correct? Right. You get like this, right? Now 2 into 1 plus 1 by 3 into 0.0025. That's it, this is enough. Because 0.0025 whole square is you can neglect. So you can simplify this. Yes, understood? I think we are fine. The value of 1 plus 1 into 3 by 2 into 5. 1 into 3 into 9 by 2 into 4 into 25, etc., etc. up to infinity. Find the value of this. 1 plus 1 into 3 by 2 into 5. 1 into 3 into 9 by 2 into 4 into 25, etc., etc. up to infinity. See, then what you have to do is, you assume this as 1 plus x whole power n. See, when you expand 1 plus nx plus n into n minus 1 by factorial to x square and so on like this. You compare. Nx is equal to 1 into 2 by 1 into 3 by 2 into 5. N into n minus 1 by 2 x square is equal to, you will get 27 by 200, right? Okay, correct? Now, you square it, divide. So, when you do like that, n into n minus 1 by 2 x square by n square x square is equal to 27 by 200 by 9 by 100. Correct? 9 by 100. So, these two will go, n will go. This is 2 times, this is 3 times. These two will go. So, finally, n minus 1 by n is equal to 3. So, 3n is equal to n minus 1, n is equal to minus 1 by 2. Now, n is equal to minus 1 by 2, nx is how much? 3 by 2. So, minus x by 2 is equal to 3 by 10. X is equal to minus 3 by 5. Therefore, this is equivalent to how much? 1 minus 3 by 5 all to the power of minus 1 by 2. This is 2 by 5 whole power minus 1 by 2. This is square root of how much? 5 by 2. So you can think like this and do this type of problems. Okay, understood? You write on this question. 1 plus 1 by 4 plus 1 into 3 by 4 into 8 plus 1, 3, 5 by 4, 8, 12 up to infinity. You have to show this is equal to root. Show that is equal to root. 1 plus 1 by 3, 1 into 3 by 1 into 2 into 1 by 3 square up to infinity is equal to root 3. You have to show those two things are equivalent to root 3. Yes, I hope you can do these two questions. The next question is coefficient of x power 6 in the expansion of 1 plus x plus 2x square into 1 minus x whole power minus 10. 1 plus x plus 2x square into 1 minus x whole power minus 10. So you have to think like this. 1 into coefficient of x power 6. X power 6 in 1 minus x whole power minus 10. Plus. See, x is already there. So I have to find out x power 5 coefficient. So 1 into x power 5 in 1 minus x whole power minus 10. Plus. 2 into x power 4 in 1 minus x whole power minus 10. 2 is already there. So x power 4. What is the formula given? X power n in 1 minus x whole power minus r is what? N plus r minus 1 c r minus 1. So n is 6, r is 10. 6 plus 10 minus 1 c 10 minus 1 plus 5 plus 10 minus 1 c 10 minus 1 plus 2 into 4 plus 10 minus 1 c 10 minus 1. Okay, right? So you can simplify this. This is 15c9. This is 14c9 plus 2 into 13c9. So this is your answer. If you want, you can further simplify this. Yes, understood? See, the next question is find remainder when 2 to the power of 2003 is divided by 70. 2 power 2003 is divided by 70. Find the remainder when 2 power 2003 is divided by 70. See, we will think like this. 2 power 2003 is equal to 2 cube into 2 power 2000. This is 8 into 70 means I write 2 power 4 whole to the power of 500. 2 power 4 is 16. This is as good as 8 into 17 minus 1 whole power 500. See, whenever the minus sign comes, I will see that there is even power here. That's what I did it. Now, this is 8 into 17 power 500, 500 C1, 17 power 499, etc., etc., etc. Finally, plus 1 here. Here minus 500 C 499 into 70. Okay, alright, this is what you are going to get. That's all. In all these terms, 17 is common. So 8 into this is a 17p plus 1 form. This is as good as 8 into 17p can be written as 17i plus 8. See, when you divide this with 17, when you divide this with 17, what is the remainder you are going to get? 8. So, remainder is 8. So, remainder is 8. So, when you divide 2 power 2003 with 17, the remainder what you are going to get will be 8. Yes, understood? next question is find last 4 digits. Last 4 digits in 3 to the power of 100. Last 4 digits in 3 power 100. That is our next question. Listen. 3 power 100 can be written as 3 square whole power 50. This is 9. 9 is 10 minus 1 whole power 50. See, whenever you get minus 1 here, I will always see that the power is even. Right? See, when you expand this, 10 power 50 minus 50 C1, 10 to the power of 49, etc., 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 finally 1. Before this, minus 50 C 49, 10. Before this, 50 C 48, 10 square. Before this, 50 C 47, 10 cube. Right? Now, if you closely look at this, if you closely look at all these terms, here 10 cube will be there. Here this is 50 C3. 50 C3 is 50 into 49 into 48 by 6. 6 8. So you get one more 0 here. So 10 cube into one more 0 is 10 power 4. So this will be in the form of x into 10 power 4. Right? Okay, understood? So this will be like this. 4 zeros, 1, 2, 3, 4, like A1, A2, A3, etc. So this number will be of the form like this. So your last 4 digits are decided by these 3 terms. Your last 4 digits are decided by these 3 terms. So we are very much interested in the value of this. Yes, understood? So here 10 cube, one more 0 will get 10 power 4. So this number will be definitely in the form of 4 zeros and then like this, A1 into A3. Now, if you observe this, 50 C8 is 50 C2. So 50 into 49 by 2 into 100 minus 50 C1 is 50. So 500 plus this is 250s. So what is the value of this? Simplify. 25 into 49. So this is 1225 double minus 499. So this is how much? 1 0 0, right? 2 1, okay, 2 1 2. So last 4 digits are what? 2001. So last 4 digits are 2001 like this. So last 4 digits in the expansion of 3 power 100 are given by 2001. See, up to this, no problem. You have to calculate the value of this properly and arrive at last 4 digits of the number 3 to the power of 100. Right? I think you are following. Similarly, you find out last 4 digits in 7 power 100. I'll just give a hint and you have to do it. You can write 7 square whole power 50. This is 50 minus 1 whole power 50. Then you will get 50 power 50, etc. Concentrate on the last 3 digits. minus 50C49 into 50 plus 50C48 into 50 square. You concentrate on this. This will give you last 4 digits. Yes, I hope you can simplify it. 50 square you know how to calculate, 50C48 is 50C2. So you can simplify that and arrive at last 4 digits of the number 7 to the power of 100. The next question is 2 to the power of 2003 is divided with 17. Find the remainder. Find remainder. This is our next question. 2 power 2003 is divided with 17. What is the remainder? You see this 2 power 2003 is 2 cube into 2 power 2000. 8 into 2 power 2000 is 2 power 4 whole power 500. 8 into, this is 16. 16 is what? 17 minus 1 whole power 500. Right? This is 8 into 17 power 500, 500 C1, 17 power 499, finally 1. Before this, 500 C 499, 17. You will get like this. In all these things, 17 is common. So this is 8 into 17p plus 1. This is 8 into 17p into 17p is nothing but what? 79 plus 8. 8 into 17p is what? 79 plus 8, where I is integer. So when you divide 2 power 2003 with 17, what is the remainder? 8. 8 is the remainder. Yes, this type of problem I did already, this model, right? The next question is find remainder. Find remainder when 32 to the power of 32 to the power of 32 is divided with 7. 32 to the power of 32 power of 32 is divided with 7. See, first concentrate on this. 32 to the power of 32 is 2 power 5 whole power 32. This is 2 power 160. Right? This is 2 power 160 is 3 minus 1 whole power 160. This can be written as 3 power 160, 160 C 3 power 159, finally 1. Before this, 160 C 159 3. This is all multiple of 3. So this is 3p plus 1 form. So therefore, 32 to the power of 32 to the power of 32 is 32 to the power of 3p plus 1. This is 32 is 2 power 5. So 2 power 15p plus 5. This is equal to 2 power 5 into 2 power 15p can be written as 2 cube whole power 5. Is it 2 power 5? 2 power 15p you can write like this. This is 32 into 2 cube is what? 8. 8 can be written as 7 plus 1 whole power 5p. So this is 32 into 7 power 5p. 5p C1, 7 power 5p minus 1. Final term is 1. This is 5p C 5p minus 1, 7. All these things, 7 is common. So you are going to get 32 into 7 cube plus 1 form. This is 7 into 32 cube plus 28 plus 4. 32 is 28 plus 4. 28 is a multiple of 7. So all these things are what? Multiples of 7. So this is 7i plus 4 form. So 7i plus 4, when you divide with 7, what is the remainder? 4. That's it. So find remainder when 32 to the power of 32 to the power of 32 is divided with 7 means first you concentrate on this. You can write 32 2 power 5, 2 power 160, 3 minus 1 whole power 160, expand it. Then in all these things 3 is common, so 3p plus 1 form. Then consider this. Then consider this. Consider this. 32 to the power of 32 to the power of 32 means 32 to the power of 3p plus 1. 32 is 2 power 5. 5 into 3, 15. 5. So 2 power 5 you take outside. 2 cube whole power 5p you write it. 2 cube is 7 plus 1. Expand it. This is a 7 cube plus 1 form. 32 into 7 cube plus 1. 32 into 7 cube plus 28 plus 4 you write. In all these things 7 is common, 7i plus 4, hence remainder is 4. Look at all this. A1, A2, A3, A4 are any 4 consecutive coefficients. Any 4 consecutive coefficients in the expansion of 1 plus x whole power n. In the expansion of 1 plus x whole to the power of n. Then a1 by a1 plus a2, a3 by a3 plus a4, a2 2a2 by a2 plus a3. How much? This is the question. So A1, A2, A3, A4 are any 4 consecutive coefficients. Which of the following is correct? Right. Now, whenever you want to do this problem, the best way is to inspect the solution. See, minimum value of n must be 3. Because if n is 3, you will have 4 terms. Right. So I will choose better n is equal to 4. Okay. N is equal to 4. Then what are the first 4 consecutive terms? 4c0. So a1 is equal to 4c01. a2 is equal to 4c14. a3 is equal to 4c2 6. a4 is equal to 4c3 4. Like this. Now substitute this. When you substitute 1 by 1 plus 4 plus 6 by 6 plus 4 minus 8 by 4 plus 6. This is 1 by 5 plus 6 by 10 means 3 by 5 minus 8 by 10. 8 by 10. This is 4 by 5 minus 4 by 5, 0. Right? So the value is equal to 0. Now listen. If I put n is equal to 4 here, 4 minus 2. So this is ruled out. This is ruled out. So your answer is what? This. So you can always check it up like this. So the best way to do the problem is like this. Especially in the examination, you are expected to get ideas like this. Yes, understood? So n is equal to, if you want you can choose n is equal to 3 also, no problem. Right? See why I didn't choose n is equal to 3? Because if I choose n is equal to 3, if I get here 1, this also is 1. Then once again you have to check up with some other number. So if I choose n is equal to 4, directly you will get only one alternative as your answer. Okay, understood? Now if you want to prove in general this problem, right, you can think like this. A1 is equal to NC0, 1. A1 is equal to 1. A2 is equal to NC1, n. A2 is equal to NC2, n into n minus 1 by 2. A3 is A2, this is A3. A4 is equal to n into n minus 1 into n minus 2 by factorial 3, 6. You can choose like this. You can substitute all these values. Still you will get same answer. Okay, understood? So this is how you have to think. See, while doing multiple choice questions, one should use his common sense and try to tackle the problems like this. But anyhow, I will show you after completing all the problems. I am going to discuss some 30 to 40 questions like this, especially multiple choice questions. The next question is x is equal to root 2 plus 1 whole power 6. Find step x. Find the value of step x. X is equal to root 2 plus 1. Find the value of step x. What is the value of step x? That is n. X is equal to root 2 plus 1 whole power 6, which is step x plus fractional part of x. Integer part plus fractional part. Yesterday I taught such problems. I think in one of my classes I discussed already this type of models. Consider capital F is equal to root 2 minus 1 whole power 6. Small f value lies between 0 to 1. Capital F also lies between 0 to 1. Correct? Watch. Capital F also lies between 0 to 1. Because root 2 minus 1 is a fraction. Fraction whole power any integer is what? Fraction. Consider x plus f. That is step x plus small f plus capital F. Consider, stop this. Okay, no problem. This is equal to, see this can be written as 1 plus root 2 whole power 6, no problem. This is plus 1 minus root 2 whole power 6. Because since this is even, whether root 2 minus 1 or 1 minus root 2, it makes no difference. So I can write like that. Now when I expand 1 power 6, 1 power 6, it comes what? 2 times. Then 6c1 root 2. Here minus 6c1 root 2, they will cancel. So second terms will cancel. Third term is what? 6c2 root 2 whole square. 6c2 root 2 whole square, it comes what? Twice. Next we will get 6c4 2 square. Next 6c6 2 cube we will get. Correct? You are going to get like this. So this is nothing but even integer. This is nothing but even integer. Yes? Understood? So the entire thing is nothing but even integer for us. So you can easily calculate this. But the value of this will get 2 into, this is 1 plus 6C2, 6 into 5 by 2 means 15, 30. Plus 6C4 is 62, 6 into 5 by 2, so 15 into 2. 15 into 4, 60. This is 8. This is equal to 2 into 68 plus 30, 98, 98 plus 1, 99. So 198. So you have got step x plus f is equal to 198. See, from these two, what is f plus f lies between 0 to 2. Since step x is already integer, f plus f must be what? Integer. What is the integer lying between 0 and 2? 1. Therefore, f plus f is equal to 1. So, step x plus 1 is equal to 198. Step x is equal to 197. Step x is equal to 197 you are going to get. So the integer part of this happens to be step x. So to get this problem, you consider conjugate of this. This is conjugate of this. This is definitely less than 1, whole power 6 less than 1. So therefore you will get like this. Add these two, you will get like this. Then consider this plus this, that is this plus this, which is this. You can write 1 minus root 2 whole power 6 because 6 is even, you can do like that. Expand it. Then you are going to get, this is all equivalent to 198. So finally what? Step x plus f is 198. Since this is already integer, this must be integer. So what is the integer which lies between 0 and 2, 1? So it must be 1. So step x plus 1 is 198. Step x is equal to 197 like this. Okay, understood? This is a very important model. The next question is, show that integer next to root 3 plus 1 whole power 2n is divisible by 2 power n plus 1. The integer immediate to root 3 plus 1 whole power 2n is divisible by 2 to the power of n plus 1. This is a very important and a standard question. Show that integer next to root 3 plus 1 whole power 2n is always divisible by 2 power n plus 1. You call x is equal to root 3 plus 1 whole power 2n is equal to I plus f or step x plus f. To show what? I plus 1 is divisible by 2 power n plus 1. Yes, understood? So you can call root 3 plus 1 whole power 2n is equal to I plus f. You have to show that I plus 1 integer next to. See, this is the integer part. So I plus 1 is what? The integer next to this. Understood? I is not that. See, this value is, let us say for some value of n, some 2.4 like that. 2 is this, 4 is this. The integer next to that is what? 3, not 2. I think we are following the point. So, I plus 1 divisible by 2 power n plus 1. So now, first you consider root 3 plus 1 whole power 2n is equal to root 3 plus 1 whole square whole power n. This is expanded. 3 plus 1 plus 2 root 3 whole power n. This is 4, this is 2, therefore 2 power n into 2 plus root 3 whole power n. plus f. Understood? Consider capital F is equal to root 3 minus 1 whole power 2n. See, when you simplify like this, 2 power n into 2 minus root 3 whole power n. Right? Now, listen, your small f lies between 0 to 1 and capital F also lies between 0 to 1. So root 3 minus 1, root 3 approximately 1.7 something. This fraction. Fraction whole power 2n is always a fraction. Consider I plus f plus f. This plus this. This plus this. What is common? 2 power n into 2 plus root 3 whole power n plus 2 minus root 3 whole power n. 2 power n into, when you expand this, all the irrational terms will cancel. We have seen already like this. And the rational terms, integer terms, each will occur twice. So 2 into integer you will get. Just now I have seen such problems. You will get 2 into integer, which is 2 power n plus 1 into integer. 2 power n plus 1 into integer. Now, what is your f plus f? F plus f is once again 0 to 2. So, I plus f is equal to 2 power n plus 1 into integer. So, I is already integer. F plus f must be what? Integer. Therefore, f plus f must be equal to what? 1 because of that. So, I plus 1 is equal to 2 power n plus 1 into integer. Hence, I plus 1 is divisible by 2 to the power of n plus 1. See what I did is, I am calling this as I plus f. I will first try to simplify this. I will send inside 2 like this. I will expand this. I will get like this. Then 2 power n will come out. 2 plus root 3 whole power n will get. This is I plus f. F value lies from 0 to 1. Capital F is equal to root 3 minus 1 whole power 2n. Simplify like this. You simplify like this. You will get like this. I plus f you consider 2 power n is common in both. 2 power n into 2 plus root 3 whole power n plus 2 minus root 3 whole power n you will get. When you expand this, you are going to get what? All the integer terms will come twice. All irrational terms will cancel. So this is basically what? 2 into integer. 2 power n into 2 into integer is 2 power n plus 1 into integer. So therefore I plus f is equal to 2 power n plus 1 into integer. 2 power n plus 1 into integer. I is integer, f plus f must be integer. What is the integer lying between 0 and 1? Therefore I plus 1 is 2 power n plus 1 into integer. Hence I plus 1 is divisible by 2 power n plus 1. Therefore the integer next to root 3 plus 1 whole power 2n is always divisible by 2 to the power of n plus 1. Right? This is how you have to do the problem. And you are expected to remember that statement. So that statement is also a very important statement. So remember that statement. This is a very, very important statement. Whenever I put something in a rectangle, try to memorize that. It will be always useful. Now, listen, you will come across problems like this. The integer next to root 3 plus 1 whole power 100 is divisible by a 2 power 101, b 2 power 50, c 2 power 51, d none of this. integer next to root 3 plus 1 whole power 100 is divisible by which of the following? A is 2 power 101, B is 2 power 50, C is 2 power 51, D is none. So what is your answer? 2n is equal to 100, n is what? 50. So 2 power n plus 1 means 2 power 51. So your answer is this. Remember 2n here, 2n is 100, not n. Should be very careful. So 2n is equal to 100 means n is equal to 50. 2 power n plus 1 means 2 to the power of 51, hence proved. Like that. If you remember the statement, you can easily do that. See, the next question is 1 minus x cube whole power n is equal to AR x power r 1 plus x square minus x whole power 3n minus 2r. Then you have to show that AR is equal to NCR 3 power r. Right. This is purely a manipulation problem. You just watch how I am manipulating. 1 minus x cube can be written as 1 minus x whole power n into 1 plus x plus x square whole power n. So I'm sorry, please correct this. It is 1 minus x. I'm sorry. You please correct it. 1 minus x cube whole power n is equal to sigma r is equal to 0 to n AR x power r into 1 minus x whole power 3n minus r. See, 1 minus x cube, you can factorize it like this. This is sigma r is equal to 0 to n. See, this can be written as 1 minus x whole power n AR x power r 1 minus x whole power 2n minus 2r. See, this 1 minus x whole power n is a constant. It may be inside sigma or outside sigma, it makes no difference because it is independent of r. So this I can cancel. So I can take outside this and cancel because these three only will change as r changes. That will not change anyhow. Right? Okay, understood? We got like this. Now this is as good as sigma r is equal to 0 to n AR x power r. This is 1 minus x whole square whole power n minus r. This is as good as sigma r is equal to 0 to n AR x power r into this is nothing but 1 plus x square minus 2x whole power n minus r whole to the power of r. Okay, understood? This is what you are having. So 1 minus x whole square, you expand it. You will get like this. Now you take this. See, this can be written as 1 plus x square minus 2x plus 2x 1 plus x square whole power n. Is it not? Okay. Oh. One plus x square minus 2x plus x minus x log. See, you watch this. 1 plus x square, 1 plus x square whole power n is there, right? Now, if you add this plus this, what you are going to get? Minus x, is it not? So therefore, shall I consider like this? 1 plus x square minus 2x plus x means 1 plus x square minus x. ER into, right. This is equivalent to sigma r is equal to 0 to n. You write AR, right? You consider 3x whole power r into 1 plus x square minus 2x whole power n minus r. So I am writing what? Extra 3 power r. You write by 3 power r like this. Okay? See, the idea is what? The idea is very simple. The idea is I want to convert this into one binomial expansion. That is the idea. Right? So AR into 3x whole power r into 1 plus x square minus 2x whole power n minus r by 3 power r you write. Now, listen. See, this can be written as 1 plus x square whole power n is equal to 1 plus x square minus 2x plus 3x whole power n. I can write like this. This is as good as, this is all A for me. This is all B for me. This is nothing but sigma r is equal to 0 to n NCR A power n minus r. Means 1 plus x square minus 2x whole power n minus r into b power r. So 3x whole power r. 3x whole power r. You watch this. This is equivalent to this. See, this plus x can be written as 1 plus x square minus 2x plus 3x. This is just like what? A. This is just like a plus b whole power n expansion. A plus b whole power n expansion is what? Sigma r is equal to 0 to n NCR A power n minus r b power r. Yes? Understood? So, you now watch LHS, watch this RHS. 3x whole power r, 3x whole power r. 1 plus x square minus 2x whole power n minus r, 1 plus x square minus 2x whole power n minus r. So, your NCR must be equivalent to this. So, by comparing, NCR is equal to A power r by 3 power r. Sorry, AR by 3 power r. So AR is equal to 3 power r into NCR. That's it. I think that's what you are supposed to get. So listen, what I did this problem, 1 minus x cube whole power n is equal to this as given. This I am writing it as 1 minus x whole power n into ER x power r like this. This I am factorizing. 1 minus x whole power n, 1 minus x whole power n will cancel. Then, this you consider, x power r. You send 2 into n minus r, 2 and send inside. You will get like this. Now, carefully you watch. You watch this. Here you are having 1 plus x square. I want to convert this into a plus b whole power n form. Means 1 plus x square minus 2x plus something. If I add, I should get what? Plus x. That's why I am multiplying with 3x, 3 power r dividing with 3 power r. So this is all manipulation skills. If you deeply think, then if you observe this, then you will get the ideas like this. See, in mathematics, the ideas will come when you are going on practicing with lot of involvement. So that's why here, in order to get 1 plus x square, I am putting here what? 3x whole power r. I am multiplying with 3 power r, I am dividing with 3 power r. Understood? You keep it like that. Then you take this. This is, I am converting into that form, 1 plus x square minus 2x plus 3x whole power n form. This is all a for me. This is all b for me. It is just like a plus b whole power n. A plus b whole power n according to binomial expansion, what? Sigma r is equal to 0 to n ncr a power n minus r b power r. Now observe this, observe this. 3x whole power r, 3x whole power r. 1 plus x square minus 2x whole power n minus r, 1 plus x square minus 2x whole power n minus r. So ncr must be equivalent to ar by 3 power r. So ar is equal to ncr into 3 to the power of r. So you can think like this. So this is one of the important questions.